Hello, good afternoon, welcome back. So this is the part 5 of the 5-part video series on data manipulations and transformation using dplyr in R Studio. So today we are talking about summarize. So we have been through filtering, arrange, select, mutate, and finally we're going into summarize. So if you have not watched the first video, feel free and go back to watch the first video to have a basic understanding of the data set, and then you can come back here and so that it doesn't get so you don't get confused about how the data set works. So we're using a data set called New York Flights 13. So basically the flight details of New York Airport in the year 2013. So the data set itself you can install using the package. Just go to the package manager over here, press install, and you can install the thing up above. And if not, just go to the first video and that will give you a better understanding. So today we're talking about summarize. So summarize is relatively straightforward compared to the others. It just take a bunch of rows and try to calculate a certain value based on the function that you put in. So this has the first example over here, as you can see, is first is group by. So group by means what is the group that you want to calculate, because if you don't group by, it will just calculate every single rows and it doesn't really get a lot of insight out of it. So how to use summarize is very similar to the one above, where the first one is always the data frame, and the second one will be the name of the column, followed by the functions, as well as the name of the source column. Okay, so these two are exactly the same. So let's go to actually they're the same. So it doesn't really make a difference how I actually explain it. So I'm gonna explain based on the second one. So in this case, the first rows over here is trying to group by the year, months, and day. So it will combine all the data on the same day into the same cluster. So and then we summarize based on the same cluster to get the mean of all the delay. So the fourth column, as you can see here, 11.54, that is the total, the average of delay in that single day, and that single day, and that single day, and that single day, and so on. Because if you actually look at the raw data as you have, or as we have over here, there's more than one flight in a day. That in exact, actually there's 2,700 of flights in a single day, and this will be able to give us the summary of every single day, using an average function. So mean is an average. You can also use sum. You can also use some other one that we will talk about down below. So if you do not want to run it by group by, we can also run it like that. So in this case, if you only need one single value, so that is the average delay over the whole year, you can actually get it directly done without the group by. But 12.6 minutes doesn't really give us a lot of insight. There's too little data over here. So let's go to the second thing over here. So this is slightly more complicated, as you can see, where we group by the destination and we summarize based on the count, distance, and delay, and we finally filter based on 20. So let's go one by one. So first of all, we group by the destination. So we want to see the index in this destination, and we count how many delays are there. So we count how many rows are there, how many destinations are there, what are the distance what is the distance travel between that and the destination, and what are the average delay of that destination travel. And we filter based on when we have more than 20, because if we have too little, it might not really make a lot of sense when the data size is too small. So as we can see, we are running everything into something called delay, and then we are piping the delay data frame. Actually, we can have a look over here. So you can see the destination, how many rows of them, so how many records do we have, what is the average distance, and what is the average delay. So we can actually pipe again this data frame into a ggplot. So in this case, the ggplot should give us the data, delay not found, as well. There's one case where spelling is incredibly important, isn't it? Okay, so you can see here, so most of the time the distance when the distance is very short, between like 500 and 700, we have the highest delay, while the distance increases, we have a much lower delay. That is in general. So we can see that genome point would actually be the circles over here, and the size is the number of flights that we have, while geom_smooth is actually just drawing a smooth straight line between the two variables. So we can kind of have a look at the data. There's also a small data that have a very long delay on a short distance, but majority of the flights are with a shorter distance and shorter delay, while certain of them, most of the longer distance flight has a much lower delay. So this is how you can actually easily visualize and understand the data just by using a very simple group by, a summarize, a filter, and a ggplot. So very straightforward in the way of understanding. Okay. And then you can also remove the number of NA. So why do we need to number to actually, what is that called? Remove the NA is because every time you have an NA within rows, the result of calculation will automatically be NA. So when they calculate the average, they see a single NA value, it will just spit out an NA, so it doesn't work. So in this case, the good thing about here is that we have something called NA remove. So as you can see just now, if we don't remove the NA, we don't have any mean, because it look at it and don't understand, it don't know how to sum, so it just give you an error. So if we just do an NA remove like we do over here, it will just calculate the averages without considering of the average value. So yeah, I forgot actually that this is the description for the one up there. Okay. So for the next one is actually a way to calculate the means departure delay based on each flight. So what we do here is that first we create a new parameter called not cancelled. Means we do not want to include the cancelled flight in the comparison and calculations because that would not be fair. So then we actually summarize based on the mean of the departure delay. So you can actually see from the output of this cluster, every day there's a mean. So yeah, it's the same. So basically every day there's a average of the difference between the mean for every day. I mean average departure delay over the day. So you can see that 1st January is 11.5. Here is 11.4, 13.6, 13.8. So there's slight difference once you excluded the cancelled flight, because those are obviously 0 and that will affect the calculation over there. So this is a little bit more what we call accurate, I would say. Okay, so with that, actually we can further calculate the number of flight delays for each of the flights. So what we're going to use is something called tail number. So you actually look at here. So tail number is actually very unique to each aircraft. So one of these actually represent a single aircraft. So it's one of the number in the tail end of the aircraft. So I'm not too sure exactly about if this is unique to the flight or unique to the aircraft, but it gives us a very clear idea of how many flights do we have and how many are being delayed using the things over here. Okay, so here the first thing is actually just do a group by and summary, similar to the one we did back here, but instead of year, month, day, we're running on tail num. So you can run this and actually have a look at the delay over here. So you can actually see this is the average delay of each of the tail number, which we have 4,000 of them. Okay, so based on that 4,000 of them, we can again use ggplot to actually plot geom frequency polygon, and we can see that most of the delay are quite short and most of it are in 0 with a slight positive, and everything above 100 is very, very low. Okay, so we can actually take this a little bit further. So instead of using a frequency polygon, which doesn't look as good, we can plot them as individual point, and we just apply what we call an alpha. So an alpha is actually a transparency variable. So we'll actually just make it a little bit more transparent so we can see the clustering a little bit better. So we're just going to put it as 1 so you can actually see why is it important. So you can see there's a lot more points that is actually gathered in the middle here, which is not visible. So usually when you have overlapping point, you would want a little bit of transparency so you can see the cluster a little bit better. So you can also change your point to something called geom scatter push something, where they'll try to jitter, if I'm not wrong, yeah, jitter. So they will actually push the points a little bit again away from each other. So apply a little bit of random noise so that you can actually see the overlapping a little bit better as well. Okay, so that's basically the number of flight and the average means delay based on each of the aircraft. Okay, so the next one actually we want to look at the average delay 1 and 2. So in actually the original data, you can actually see from the departure delay here, there's some negative number. So what is the meaning of negative number? As we have said earlier, is that the aircraft leave the airport earlier than expected. So in this case, if we exclude the negative delay, we can actually see a significant average delay. Yeah, if we actually remove the negative number, we can see the increase in average delay numbers basically, because the average now not considered at all. And you can actually see in certain time and certain day, the average delay is actually negative. Means in that day, we have most of the flight leaving the airport earlier. And yeah, of course, that contributes to the average delay to be slightly lower as well. Okay. So let's go to the next one. So why is distance to some destination more variable than others? To be really honest, I have no idea. But what the equations here, what is the code indicates here is that we group by the destination, we summarize by the destination, where we create a new variable called distance standard deviations, and we use the standard deviation calculation on the distance column. And this will actually see that in certain location, the average distance varies by almost 10 miles, km, something, I don't know. It's one of it. But in certain situation, let's go last one, where, certain situation like this, the deviation is very, very low, and certain situation deviation is very, very big. It might be the record problem, it might be a human problem, it might be a system problem, it might have two airports, I have no idea. So there are many reasons of why this could happen, because it happens to every single destination. So unlikely there's two airports in all locations. Okay, so let's go to the next example. When do the first and the last flight leave each day? That's fairly straightforward. You can just group by the day, and then we can summarize based on the minimum and the maximum departure time. So actually you can get the first and the last is, so remember the departure time is actually using a character base. So it's a little bit confusing to look at, where 42 is actually midnight 42. So 042 means it's midnight and 42 in the morning, and actually last is 11:56 at night. So yeah, remember that this is not being arranged properly. So I mean, this is not arranged based on the earliest, but arranged based on the day. So if you see the number doesn't really sort quite well, it's because they're arranged by the day and not by the value of the first and last. Okay, so let's go to the next one. When you leave a group by variable, each variable peel off one level of grouping, that will make it easier progressively to roll into a data set. Okay, so this is actually the same situation where we just summarize by the number of flights per day. I think this is easy enough. And we can also lastly do an ungroup. Okay, so why is ungroup useful? Because when we are calculating things gradually, then suddenly you want to calculate things based on overall, but you don't want to go back and then re-access the original parameter. You can actually use the ungroup. In this case, daily is already grouped by the year, months, and day. And what you can do is ungroup, which will bring it back into a huge data frame, and you can summarize the flight directly. So in this case, 336,776 is 336,776 over here. So it means they're all the flight. So if you don't do the ungroup, if you don't do the ungroup over here, you will actually get the same thing above here. But if you ungroup it, you only get a single value, because now they're no longer grouped together. I think makes sense, hopefully. So we're gonna go through a summarize exercise. So this is gonna be a long one. I think I'll spread it into another video. So for now, I will go to the exercise video and I will do this in the next video. For now, goodbye. I really don't do this ending very well, isn't it? Bye.